Okay, so this was the fall 2021 AMC 10B and the AMC 12B. First, a quick statement. I will have another feedback thought process about this whole test and where we go from here, aftermath kind of video like I did in the February tests. First, I just want to say, what are my thoughts, just immediate thoughts of this test? If you were taking the AMC 10, if you got frustrated, I think that's valid. There was, even me, I'm usually pretty good at not being frustrated. There were a couple problems that, man, I kept trying this way and then that way and then this way, and there was way too much time lost. And you start to feel that pressure. You feel the seconds, the sands of the hourglass draining out. The pressure starts to increase. You have to skip, and you didn't want to skip because you really wanted to get that right, and you told yourself you should. It's only number blank, and then you didn't. And so I understand how those things occur. I don't know what can be said about that. The main thing I guess you could say is this: not every performance is going to go as you desire. That's just how it is. Even the greats in every sport have performances that they don't go as well as they would like. They don't win their championship. They don't win their game. And these are professionals, right? And you too as well. If you had a bad outing, that's it. It's a bad outing, okay? In addition, I'll have further thoughts on the direction we might want to go in depending on how we performed. Now, if you are somebody who hit a home run, right? You really knocked this one out. You got 23 out of 25. Let's probably resist flexing in the forums. You know who you are. You're or the people I'm talking about. Oh, do you think that 144 is enough to qualify? I'm not sure. Maybe you guys could tell me. No, they know that they should know. I mean, if you're getting that kind of score and you don't know, I don't know. Let's try to not do that in my comments, especially. Let's respect people who had a little bit of a struggle with this one, and understand where they're coming from. My guess is if you scored 111 or above, I mean, I don't think that's the cutoff, but I would say it's safely a comfortable number. If you're above that number, my guess is you qualified for the AIME on the AMC 10. For AMC 12, I don't have a prediction on that yet. Again, my prediction is not a 111 cutoff. It is that would be safe, for fully safe, okay? I think the top 2.5%, I'm getting a feeling around 105 or 106.5. Again, top 2.5% is no longer the cutoff, right? You can take as high as a percent as they want now. It's dependent on how many people took the test. And so, yeah, don't think that's the cutoff. That's just my gut feeling for where the top 2.5% delineation will be after taking the test myself. The main thing is, again, if you had a bad outing on this, I really feel for you guys. There'll be a video coming out talking over the weekend about where we go from here. Part of that will discuss the off season, which is what we call the period immediately following the exams, 3 to 6 month time, and what we should focus on there. Stay tuned for that one, but for now, let's get started on this test. From problem number 1, what is the value of 1, 2, 3, 4, all this, right? Your ability to make observations and capitalize on them as quickly as possible is crucial to how fast you can run through the first few problems of the test. And to be honest, every second counts, because some of the later questions, when you're solving it 5, 6 different ways and none of them are seeming to bear fruit and your emotions are starting to go a wreck, these seconds will be crucial to give you time to recover so that you can move on to other questions that you may be able to do. So what observation am I talking about? You should notice they're all 4 the same types of numbers, right? There's a 1 and 2, a 3 and 4 in all of them, and the 1 occupies all the positions, as do all the rest. In fact, it just shifts over 3, 4, 1, 2, and then 4, 1, 2, 3. Because of that, we can rewrite this as 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4. You just rearrange it. Add the first column, get 10, add to get 1. 4, 3, 2, and 1 is 10. Again, you have 10 plus 1 is 11, and 11, and 11, and that's going to be it, 11,110. If you saw this observation, you capitalize on it pretty quickly as I did, great. If you didn't, don't worry. This is what we gain experience for so that we can learn to make these kinds of observations. With that said, let's get on to problem 2. All right, continuing with the fall 2021 AMC or 10B and 12B, both of them, problem number 2. What is the area of the shaded figure shown below? This is an isosceles triangle minus the smaller isosceles triangle, and it's really just half base. This is a typical shaded region problem. I'm sure most of the experienced test takers were not too troubled by this, and if you're inexperienced, don't worry, this is how you gain experience. So half base, be careful, this is on 5, but the base is not 5, the base is 4. So it's half the base times the height, which is 5. Of what we're looking at is the whole triangle as if this was shaded too. And then we're going to subtract the unshaded, typical standard shaded region approach. Minus half times, the other one has a base of 4 but a height of 2, so it's 4 and 2. So half of 20 is 10. Half of this is 4. 10 minus 4 is 6. Answer choice B. And we're doing problem 3. Okay, so continuing with the fall 2021 AMC 10B. This is problem 4. Also the 12B problem 3. At noon on a certain day, Minneapolis is n degrees warmer than St. Louis. So we don't know if the time matters right now. I'm going to write Minnesota and St. Louis. And we're going to say that it's x here and x plus n here because it's n degrees warmer than St. Louis. At 4 p.m., the temperature in Minneapolis has fallen by 5 degrees. So now it's going to be x plus n minus 5, while the temperature in St. Louis has risen by 3. You've got x plus 3. At which time the temperatures in the two cities differ by 2. Okay, what is the product of all possible values of n? The thing is, we don't know which of these two is bigger right now. And so we're going to kind of need to do the absolute value thing, where you're going to subtract, right? And that needs to be 2. So I didn't actually write the absolute value on my paper when I was solving. I just thought about the necessity of it because if that one's bigger, it's going to be reversed. And so I set it equal to 2 and negative 2. I did notice that the x will cancel and n minus 5 minus 3 will be n minus 8. I set that equal to 2. I also set it equal to negative 2. So you would get that n is 10 and n is 6. 10 times 6 is 60. Again, the reason that you don't know is you don't know if when it went down 5 and this up 3, if that made this expression larger. One more time, if you don't know how the difference in an absolute value works, it's going to be kind of a piecewise function. It is this without the absolute value if A is greater than B or equal to. And it's going to be the opposite, B minus A, if A is less than B. That's a small notebook concept. You need to have it so that at this point you're not losing time. So 10 times 6 is 60. The only thing alarming to me is what about this 120? What if there was a possible difference of 2 and I just haven't thought about it? So if I think about it, how could I have a difference of 2? If this one goes down 5 and up 3, you've got the x's canceling. Could I possibly get n equals 2? If n was 2, right? Let's just say n was 2. Minneapolis would have been x plus 2 and this would have been x. If I go down 5 from here, I'm now at x minus 3. If I go up 3 from here, I get x plus 3. That's going to be a problem because those don't differ by 2, they differ by 6. Therefore, I know this is impossible, and I know that it's this, and that knowledge that you did not make a mistake for certain, absolutely critical as you advance forward in the test. Otherwise, it plagues your thoughts as you go forward and causes more mistakes to happen on the back end as the stress levels increase. And they're going to be increasing pretty soon here. Let's get to it. We are doing the Fall 2021 AMC 10B, Problem 5, the 12B, Problem 4, and this is not a promotion. This is a box of Cheerios, though. I don't really advocate you eat Cheerios, you eat whatever you want, but they're here for a reason. Why might I have this? Let's say that you rolled out of bed one morning and you decided to have, or maybe you ate it at night, no judgment, and you decided to have yourself a bowl of Cheerios. If you ask yourself, what did you just eat? And you would tell people, Cheerios. But you would not be telling the full truth. You did not eat Cheerios. What you ate was vitamin D. You can see here, right? Vitamin D at a certain amount. It's kind of probably blurry because it's not made to be focused on this. Vitamin D, calcium, iron, potassium, fiber, sodium, cholesterol, carbohydrates, trans fat, saturated fat, total fat, right? All these different things, vitamin B6, niacin, thiamine, all these things. That is what you ate. If you look at this and you see a box of Cheerios, that's the problem. If you look at this problem here, let n equal 8 and you see an 8 and that's all you see and you don't instantly see all the things that are in that box like that, then you're going to have to change your frame of mind. I do not ever look at this and see 8, ever. I see 8 and instantly it's 2 to the third. Instantly, instantly, instantly. If you see 24, I don't. I see 2 to the third times 3 to the first. You say 36, I say 2 squared times 3 squared. I've trained my mind to see it as its prime factors, provided that it's a low enough number. Obviously, if it's a huge number, I'm not going to know instantly what the prime factorization is. But most things under 100 I can do within a second or two, okay? So at the same time, when I see 8, I recognize it as the cube of 2. And you're going to have to train your mind to do that as well. So this becomes n equals, I don't even read the sentence. I just look and I know what they want because it's happened so many times. It's pattern-based behavior. And you're going to see 2 to the third to the 2022, which is 2 to the 6066. Which of the following is equal to n over 4? Did you just say 4? No, it's 2 squared. This is n. We just talked about this, right? So this is 2 squared. Subtract, get 2 to the 6064. Then look for this first. Do you see it? There's the only 2 right here. I don't. Let's start making it something different. If I made it 2 squared to the x, this product 2x needs to equal that. So x would need to be half of this, which is 3032, which is e. And you can do this problem, if I'm not explaining it, in 30 seconds or less. Tops. Okay? So train your mind to look at numbers and see beyond the veneer. See behind what it shows. Look for its ingredients. Don't see it at its face value. The same thing's kind of true of people. Let's get on to the next problem. Okay, so let's get to this problem, the Fall 2021 AMC 10B, Problem 7, also the 12B, Problem 5. Okay, this is where it really started to get like a big time sink. I think a lot of people probably hit this. I don't know of any really quick way to do it. I would probably describe this problem as how quick can you come up with a systematic process, an algorithmic process that you can capitalize on, and how fast you move through that process. It's basically that. It is a time sink. It's meant to drain your time. Who can come up with a strategy and execute that strategy as quickly as possible. To my knowledge, and maybe I'm wrong, there's not any really simple underlying way to do this. So let's go through it. Call a fraction a over b not necessarily in simplest form. Special if a and b are positive integers whose sum is 15. So, not necessarily in simplest form. Let's just write the first one, 1 over 14. And we'll just go ahead and write them all out now. 2 over 13, 3 over 12, 4 over 11, 5 over 10, 6 over 9, 7 over 8. You might think that's all, but you gotta flip them. Sorry. Because fraction doesn't say that it's, a reduced form or that it's a, less than one fraction. It's still called a fraction if you flip it. So then you're going to also have 14. I'm going to write the integer ones down below. So 14 would go here, which is 14 over 1. And then you'll have 13 over 2. and then 12 over 3 is 4, and then 11 over 4, and then 10 over 5 is 2, and then 9 over 6 is 3 over 2, and you have 8 over 7. So now, again, if you separated the integers, this is kind of the system that I used, you're going to be able to go maybe slightly quicker than you would otherwise. Let's see what it wants you to do. How many distinct integers can be written as the sum of 2, not necessarily different special fractions? So I can have twice one of these if I want. Let's grab the low-hanging fruit. We're going to do all of these doubled. So you're going to get 28, 8, and 4. Then you're going to combine any two of them. So 14 and 4 is 18. 14 and 2 is 16. 4 and 2 is 6. Okay, next I'm going to come up here and cross out all the ones that reduce. It'll be easier for me to think about. This is 1/2. This is 2/3. Okay, we also had 9 over 6, which I already reduced as 3 over 2. So first, the thing with 14, you're not going to be able to get it unless something is equal to 13 over 14 at minimum. And that's already well over 15, 13 plus 14. And if I doubled it to make it larger, it's not going to get better. So you're not going to find any for this. You're not going to find any for the sevenths for the exact same reason. I would need to have at least 6 sevenths, which is 13, not going to give you 15. So not going to work there. Same problem that 13 is going to have. I would need 11 over 13 to combine. I've got nothing. So I still have this 1/4 to work with. I'm going to write it. I'm going to erase this 8 over 7. I'm going to list the 1/4 right here. I've also got the 11ths here. We've got 4 11ths, and that's going to have the same problem as well. It's going to need 7 11ths, which is already 18. Or at least that, right? You could also have other ones, but they'd all create sums that are larger than 15. So that's not going to do any better. So we got the 1/4, we got 1/2, and you've got 2/3, and you've got 7/8 as possible. Now, the next thing I'm going to do is double all of the ones, which means I'm adding 2 of those. Double all the ones that have a 2. That's going to give me 13, 6, and 1. So, sorry, not 6, 3. 13, 3, and 1. I doubled this to get 6 and forgot to divide. Should have just knocked off all the denominators there, but it is what it is. Okay, so now what? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We're at the bottom end down here. Is that it? We're going to have to inspect to find out. Probably not. Let's combine things that have 2's. 13 over 2 and 3 over 2 is 16 over 2, but that's 8 and you already have it. 13 over 2 and 1 over 2 is 14 over 2, that's 7, there's another. 3 over 2 and 1 over 2 is 4 over 2, that's 2, you've got another. So now we've gone from 9, we're up at 11, and from here 11 over 4. So I'm going to just try and combine this with other things. I'm going to march it all the way across and check to see if it works. So if I doubled this to 26 over 4 and added it to this, you can just think this ends in 0.5, that's going to end in like a 0.75, and that's never going to make an integer. 0.5 and 0.5 could, 0.5 and 0.25 never could, 0.5, so that kind of thinking, switching to decimals to like analyze and stuff like that, all of those seconds that you can shave off your solve time are going to pay you dividends and give you more time to deal with the even more frustrating problems coming later. Assuming that you also had frustrations like I did with some of them. So 13 over 2, 14 over 2, we got that already. And then we can't do this. This is going to be like 0.6 repeating with a 0.5, never going to get it. This is going to be a 0.125 kind of thing. Actually, it's 0.875 is what it's going to be. And that's not going to add with this to make anything. So we're done with that one. This is going to be a 0.75. I'm going to need a 0.25 like this. We've got that one already here as 12 over 4, which is 3. So that's done. You're not going to find any more of those. The 0.5s can only combine with other things that end in 0.5, and we've already thought about those. This one plus that one and so on. So you're not going to get any more of these. This is a 0.25. It's going to need a 0.75 to go with it. I don't have any more left. You're out of those. I'm only moving this way. I'm doing this one with all of them, this one with all of them, this one with all of them, and that way I don't have to worry about any that I've already crossed out. I feel a lot more comfortable at the end of my problem. Same thing here, you've got a 0.5, a 0.6, and a 0.875. Those never make an integer. You've got 11. That's going to be the answer. Double check we didn't overcount anything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you have enough time at the end of the test, write them in order from least to greatest to make sure that you're not making a mistake, because there's lots of nice things around that number that would cause mistakes. Let's get to the next one.